Hello there, everyone. My name is Crazy Caleb, and today we're going to be taking a look at Mechanus Cipher. So this is the first module of the two of the planar ciphers, as they call them, and this is actually the harder of the two. I covered Pandemonium in a previous video a little bit like a couple weeks ago, and now we're going to be taking a look at the harder variant. But of course, we have a 7-letter encrypted word, as we normally do, and we're going to have to cycle through several of these different displays, and this module is actually not too bad. It's the second step that is really the worst part of this module. And it's not necessarily bad, it's just, it is a very tedious process, and it is very easy to mess up. So let's get right into this. So, as you can see what I just did there, I pressed any of these panels here, and what we're going to be doing is we're going to be getting a series of different screens here. There is 3 screens on the top, and I believe there's just 2 on the bottom. No, there is 3 on each of them. Along with a little letter Yankee, which cannot be interacted down here. This letter is sort of your key letter, so keep that in mind. And the way you submit this is the highlighted one that is present on the gear is going to be your submission, and it will pop up on the rightmost display, and each time you input a letter, it'll simply move to the left one. So that's what we're going to be doing. And we have to find a word, 7-letter long word, as we normally do, and let's get our entire read once light turn back on. So for the top display, for our encrypted word is going to be Foxtrot India Delta, X-ray Papa, Tango Delta. Next up, we're going to get Noctuid, so Noctuid, and finally a binary code of 0011 0011. Excuse me, 001. Okay, and that's going to be our top display. This out. Next up, we're going to get a series of two different numbers, 527 4774. Then next up will be a 446 1365, and then finally it was a ranters. That's another keyword that we will be using. So now we'll get the key letter that we have on that little right side, which is a Yankee, and we should be good to go. So now let's start getting into this module. This module itself is very, very tricky to do, but again, it ultimately comes down to the second step that's really going to screw with you. So for our first part, we actually need to create a specific key, which we're going to be using for all steps 2 and 3. These are simply just words that we have here, ranters and noctoid. We're going to be using those for various steps. So for steps 2 and 3, you're going to need a key. So we actually won't be using this in step 1. So to make this key, we're going to take the keyword from the top of the row, from the top row, which is noctoid. So we're going to take noctoid to here. Noctoid. Let's see if I can type it out. Jesus. So, and then what we're going to do is we're going to repeat it until you have 26 letters. So we're going to just simply do a copy and paste until we reach over 26 letters, which is going to be a column 27 right there. So now what we're going to do is we're going to do, for all letters in the string in reading order, if a letter has already occurred, we're going to shift it forward in the alphabet until this is not the case. So we're essentially going to be creating, we're going to do noctoid. There's no duplicates in noctoid. And now the next N is going to be shifted 1 forward in the alphabet. We already have an Oscar, so next up is going to be a Papa, which we do not have. And essentially what you're going to do is you're going to do this for every single character until you have all 26 letters of the alphabet. They all must be unique, and that's the way that this is going to work. Then next up, Oscar. Next up will be Papa. Then we don't have that. We have a Quebec. We don't have a Quebec though. So that's going to become a Quebec. Charlie is going to become a Delta. However, Delta is already present, so we're going to be going to Echo next, which is not present. Tango is going to be next up to Uniform. Uniform is already present, so that's going to be a Victor. Really annoying case, but whatever. Uniform next up would be Victor. However, we already have Victor, so we're going to go to Whiskey. India next up is going to be a Juliet. Nothing there. Delta, we already have Echo, so that's going to be a Foxtrot. So that's next. Now in November, we did Papa last time for it, and we did Quebec, so that's going to be next up after Quebec is going to be a, I can't think, Romeo. And then after the Oscar, and then the next one after the Oscar is going to be after the Romeo, which is going to be a Sierra. Then Charlie, we already have already have Delta, we already have Echo, we already have Foxtrot, we don't have Golf, that's one right there. And then for Tango, we already have Uniform, we already have Victor, we already have Whiskey, we don't have X-Ray, so that's going to be X-Ray, and then the letter after that is going to be a Yankee. And then India, we already have Juliet, we already have, we do not have Kilo though, that's going to be next. Delta, we already have Echo, Foxtrot, Golf, Hotel, we do not have Hotel, so that's going to be Hotel. Then next up, we have these last 5 letters, November. The next letter after that is going to be, it would take us to Sierra. Then we go to Tango, and then we're catching up to this point, so that's going to next up be a Zulu. And then we're going to do Alpha. Charlie is going to take me to a Lima, I believe. Charlie, Delta, Echo, Foxtrot, Golf, Hotel, India. Yep, and then we have Juliet, Kilo, and then it's going to be a Lima. And then Tango is going to take me to Bravo, because we don't have that. And then Uniform, lastly, should be a Mike. And just like that, we already have our key. So we're going to keep this for the side. That is step 0. We already have our key created. And now, this step, we're actually not even going to use the key at all. We're simply going to do a pancake transposition, which is actually the easiest part of this entire thing. So we're going to be taking our encrypted word from the top row, which is FIDX PTD, which is going to be right down here. And now what we're going to do is we're going to take the first number from both strings and mirror the group of letters that are positioned between these, including those 2 numbers. So what's going to happen is that we're going to essentially take each individual column, like the first number, then the second number of each, then the third number, so on and so forth. And what we're going to do is between this range, we're going to mirror every single one of those characters. And that's going to be inclusive with both of these numbers. So in this case of 5 and 4, all we're essentially going to be doing is going to be swapping these 2 digits. So the 5th position is Papa, and the 4th position is X-ray. We're essentially going to reverse this range, which is just going to be Papa X-ray. Pretty straightforward. However, with bigger examples, it can be very, very tricky. So next up, we have 2-4. 2-4 is going to be between India and Papa, so it's going to be Papa Delta India right here, and we're going to pop this right back in. Like that. Next up, we're going to do 7-6. That's just another swap. That's going to be Delta Tango right here. Delta Tango. Then next up, we have a 4-1. Here's where things get a little bit interesting. Between ranges 4 and 1. We're going to reverse these guys. So it's going to be India, Delta, Papa, Foxtrot right there. And we're going to pop you in like so. Then next up, 7 and 3. So it's going to be a Tango, Delta, X-ray, Foxtrot, Papa. Like that. We'll get rid of you, and we'll pop you up right there. So we did 7-3. Let's do 7-6 again. Lovely. Papa Foxtrot right there. Papa Foxtrot. Then next up for our last one will be 4 and 5 once again. 4 and 5 is going to be X-ray Delta, and that's what we're going to pop into the module, X-ray Delta. XD. And that is step 1 taken care of. This is doing these numbers. That's all good. Now, welcome to hell. All right, so now what we're going to be doing is we're going to be using our key, and I'm going to put this guy back up top because we're simply going to leave that alone for a little while. So now what we're going to do is we're going to take the encrypted word from the previous step, which I said I was going to do. I said I was going to leave up here, but I was wrong. Okay. The key from step 0, which we're going to now use this guy, and the key letter on the extra panel, which is the Yankee, and the binary string on the top row. The binary string on the top row being right here. So let's take all of these guys and let's start. You know what we need to do. So we need to make a column of your keys, letters, and columns, and a column of decreasing 4 bits binary numbers starting from 1, 1, 1, 1. So as you can see in this example, we are going to have our key on this left side, our 26-letter key here, and we're going to have a series of 16 different 4 bits here on the right side. However, what I'm actually going to do is I'm actually going to rearrange this a little bit differently. What I'm essentially going to do is I'm actually going to copy all of this. However, to make my life a little bit easier, I'm going to group these guys into groups of 4. I'm going to create a row of 4 of each of these binary bits, which should leave me with 4 rows of 4. That's going to be 16 of them. So let's copy all of these guys right here. Let's set everything up. It takes a while to set everything up, if you haven't realized. So now let's go over, let's see what we have here. All right, and now we have that set up. So what's going to be happening is that we're going to essentially, and I'm going to leave this key as a row for right now because it's just a lot easier to do this instead of doing the whole column setup, in my opinion. So I'm going to leave these guys as a row, and I'm going to set these guys up as a 4x4 grid, and you'll get into why it's going to be a lot more helpful instead of setting it up as a column. So what exactly are we going to be doing with this? So we have the column of decreasing 4x4 bits, which is in a 4x4 table, and now we're going to start at the 0, 0, 0, 0 on the binary column. So I'm going to mark an asterisk where we're at right now, and start at the key letter on the key column. So we're going to start at the Yankee in our key here. So we're going to take a look at this Yankee, and I'm going to put an asterisk below it. Like so. This is where we're currently at on each of these guys. This is where things get a little bit interesting. So then what we're going to do is then we're going to move up both columns simultaneously, wrapping around if necessary until you hit the first letter of your encrypted word. And note down the current value of the binary column. This is where things get a little bit interesting. So moving up in this case would be counting as left, because essentially what's going to happen is we start at the 0, 0, we're going to move up, and we start at the Yankee and we're going to move up, which is simply us moving to the left. So what we're going to do is we're starting at the first character is in India from the encrypted word we got from the previous step. So we're going to be moving a series of different times to get to India, and we need to count how many times that is from Yankee to India, and that is going to be our next location. And then we're going to need to count that many times in the binary column to get a 4-digit binary, which we're going to note down later on. So we're going to repeat this for the other letters and then start from where you just ended. So we're going to note down where we ended each time. So let's go over and let's count how many times it takes to get from Yankee to X-ray, or Yankee to India, excuse me. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it takes me 13 times to get over to India. So what we're going to do is we're going to count each 4x4 bit, and we need to go up, essentially. It's going to be left and then up, looping around. And we're going to need to do that 13 times. So from here, we're going to go 1, 2, 3, 4, and then I'm going to do multiples of 8. So it's going to be multiples of 4, excuse me. Then we're going to do 8, then 12, then 13, and this is where we're going to end up right here. So we're going to note down this value, 1101, and this is going to be our next beginning location from this point on. So now what we're going to do is we're going to find the next letter in the next encrypted word is going to be a delta. Keep that in mind. This is going to be a bit of a weird case. So now what we're going to do is we're going to essentially go to the left. Even though delta is right next to us, we're going to still go to the left because we need to count however many times it takes to get to this point, so we can count this many times in our binary column, or in this binary table here. So we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and of course 25. And this is going to be our new starting point. So now, one of the key tips with this is that the reason why I have this set up is because of the fact that all we need to do is we need to simply just modulo this by 6. I don't know why this is so large, and it shouldn't be that way. There we go. All right, quite massive calculator. Thank you very much. I don't need that. So what we're going to do is we're going to take the 25 that we need to count, and we're going to just simply minus this by 16. And now what we're going to do is from this point on, we're simply going to count 9 times. So 1, 2, looping around back down to the bottom right, 3, 4, 5, 6, 7, 8, 9. And that's going to be a 0, 1, 1, 0 for that stage. So 0, 1, 1, 0 is now going to be our new starting point. And now we're going to count to tango. So it's going to be 1, 2, 3. Simple as that. So all we need to do is count 3 times. So 1, 2, 3 right there. And that's going to be a 1, 1, 0, 0, 1 for that stage. Okay. Then from tango to X-ray, actually that's going to be a little bit of a distance. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, like that. So now we're going to go over to the X-ray. So we're going to count 12 times in the binary column. So we're going to do 4, 8, and 12, just like that. And that's going to get me to a 0, 1, 0, 1 for that one. All right. And now from the X-ray, we're going to go back to the delta. So that's going to be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to go to the delta 11 times. So that's going to be a 4, 8, 9, 10, 11. The 0, 0, 0, 0. So this is why I've set it up as a 4x4. It helps you use multiples of 4 to make your life a lot easier, and that's kind of just the way that I tend to use it. So we're going to go over to the delta now, and we're going to find Papa, which is going to be 25. Immediately right off the bat, I can already tell you that. That's going to be 25. 25, as we just did, modulo 16 is going to be a 9. So from 0, 1, 0, 1, or excuse me, from 0, 0, 0, 0, my bad, we're going to be counting 9 times. So 4, 8, that's going to be a 9. That's going to end us up at 1, 0, 0, 1. And finally, from the Papa, we're going to find Foxtrot, which is going to be over here. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 minus the 16 only wants us to do 4 times. So from this 1, 1, 0, 0, which we're not at the 0, 0, 0, 0 anymore, we're going to simply go to this guy, which is a 1, 1, 0, 1. So now we're currently at a final position of Foxtrot for this stage, and we're currently at 1, 0, 0, 1. Now what we're going to do is we're going to try to essentially crypt this. So what we're going to do is we're going to append all these binary numbers into one big string and split them up into 4 equal groups and set it up as a table. That's essentially what we're going to do. So let's take a look at this. So let's split all of these guys up. So this is currently 28, so it's going to be rows of 7. So now what we're going to do is we're going to read the column of the first binary table from top to bottom, and starting from this place where starting from the place you previously ended up at, we're going to move up both columns until you hit this binary instead. So instead of hitting the letter we normally would do, we're going to try and hit the binary. Now, this is where the binary string that we had from the module display right here, actually on the top display, this is where this is going to come into place. If your first digit of this binary string is a 1, we're going to shift up until you hit the same binary string again. However, if it's a 0, all you simply need to do is you simply need to loop around to that at one time. So for example, we need to get to 1, 0, 0, 0. So from 1, 0, 0, from 1, 1, 0, 1 to 1, 1, 1, 0, that's going to take me to, where is it? Right there. So we need to figure out how many times we need to get from the 1, 1, 0, 1 we have right here to the 1, 0, 0, 1. Now, if we had a 1 in this position, we would count the amount of times it would take us to get for the 1, 0, 0, 1, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And what we would essentially do is if it was a 1, for example, let's just theoretically say that was a 1, what we would essentially do is we would essentially try to get to this position and loop it back around again. It wants you to shift up until you hit it again. So basically what you're going to do is you're going to add 11 plus 16. At that point, you'd be shifting 27, and it actually would be a really easy case. However, in many cases, it could be a little bit longer. However, since this is a 0, we're only going to shift 11 times. So from our Foxtrot, we're going to shift 11 times to the left. We're going to still move up. We're still going to move to the left. However, we're going to shift 11 times here. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to take me to Charlie. And that's what we're going to do. So now from our previous position, from the previous position that we ended up on, so we're going to end up on Charlie. That's going to be right there. Now we're going to take from 1, 1, 1, 0, 0, 1, or excuse me, 1, 0, 0, 0, we're going to go to 1, 1, 1, 0. So we're going to go to right there and count how many times that is. It's currently marked as a 0 in this position, so we're not going to be moving it to it again. So we're going to go 4, 5, 6. So we're going to move 6 times from the Charlie, so we're going to go 1, 2, 3, 4, 5, 6. So that's going to take me to Alpha. And now we have, we are currently at the 1, 1, 1, 0 right here. Now this is a 1, so we're going to be going to 0, 0, 0, 1, so right here. And we're going to be going to it again. So from 1, 1, 1, 0 to 0, 0, 0, 1, we're going to go 1, 2, 3. However, we need to hit it again. So we have 3, it takes us 3 to get there, plus the 16 is going to be 19. So we're going to move 19 from the alpha we previously had, so I forgot to set that. We're going to move 19 spaces to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. That's going to be a tango. That's where we're going to end up. So we're going to go to tango, and we're going to be right there. And we're still going to end at 0, 0, 0, 1. So now from 0, 0, 0, 0, 0, 1, we need to get to 1, 0, 0, 1. So we need to get to, where are you? There you are, 1, 0, 0, 1. And this is another 1, so we're simply going to be adding 16 to whatever we get, which is going to be a 4, 8. That's going to be 8 plus the 16. 8 plus the 16. We're going to be moving 24 times, but in this case, this is the alphabet, so all we simply need to do is we need to move 2 to the right, which is going to give me an India. So we've done that, so we're now currently at 1, 0, 0, 1, and now we need to get to 0, 1, 0, 1. 0, 1, 0, 1 is going to be right here. That is going to be a 4, 8, 12. That's going to be 12 that we're going to be moving. So from the India, we're going to be moving 12. So 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12. That's going to take me to kilo. All right, so now we're currently at 0, 1, 0, 1, and we're currently at a kilo right over here. We're going to go to from 0, 1, 0, 1 right here to a 1, 0, 0, 0, which is going to be 1, 2, and 3 spaces. So we need to move 1, 2, 3 to get me to Gulf. And finally, for the last one, we need to go to 1, 1, 1, 1 from 1, 0, 0, 0. So that's going to take me to 1, 2, 3, 4, 5, 6, 7 spaces. However, this is a 1 in this position for that binary number at the bottom here. So we're going to be simply adding 16 to that. So we're going to add 16 to 7, 16 to a 7, which is going to be 23, or simply 3 to the right. So 1, 2, 3 will take me to kilo. And just like that, we have completed the second step, finally. As I said, this is probably the trickiest part of this entire module, and this actually quite frankly makes the module, in my opinion. And now for our final step. So we're going to take the encrypted word from our previous step. We don't care about the binary string anymore. We don't care about this whole binary shit right here. So we're going to get rid of all of the Q. But we are going to be using the key again. So let's keep that in mind. And what we're going to do is we're going to take a look at the encrypted word from our previous step, the key from step 0. Yep, we have that right here. And the keyword from the bottom row, which is going to be a ranters, like so. Let's put this guy below our encrypted keyword here. And what we're going to do is we're going to make a 3x3, a 3-dimensional 3x3 grid with our key. So what we're going to do is we're going to make, we're going to do 3, 6, and 9. And now what we're going to do is I'm going to place some bars to separate them from one another. And then we're going to do this right here, U right there, and then U, U, and U, and then finally U, U, and then there should be a hash at that last position. And just like that, we have our 3x3 thing set up over here. So now, what we're going to do is we're going to look up the first letters of both the encrypted word and the keyword in this grid. So we're going to take a look at the Charlie and the Romeo. So we're going to find Charlie and Romeo here. And what we're essentially going to do is we need to look up for each grid access if the positions of the two letters match. So what this means is essentially either the row or column. If they match, what we're essentially going to do is it will lie on that same position. If they don't match on your axis, your letter will lie in the unused position of that axis. That's why there's 3 of them here. So if we take a look at the Charlie and the Romeo we have here, in each of the positions, they're each in the third column of each of their grids. So what this means is that this is going to be in the third column. However, if this happens to be in different rows, so you can look, these guys are both in different rows. Charlie's in 1, Romeo's in 2. What this means is that we're going to be using the other one in this case. So we're going to be using the third row. So third column, third row will take me to a hash. If this is a hash, it is the letter of the encrypted word instead. So what this means is that it is simply just the Charlie. Because of the fact that this was the position that we're looking at, this is part of our encrypted word. This is what we're looking at here. If it lands on this hash, it simply does not change the encrypted letter. That means that this is the normal letter. And we're going to repeat this for all steps of the encrypted grid. So we're going to take alpha and alpha, which means that this is going to be the same position. And keep in mind, they actually could be potentially in the same little grouping of the 3x3 grid. But essentially what you're going to want to do is you're going to compare the rows. Are they the same? If they are, use the same row. If not, use the other row that they don't. Use the other row that is not being used. But in this case, alpha and alpha, they're in the same group right here. They are in the same row and they are in the same column, so they are the exact same. It's going to be a Charlie, and it's going to be an alpha. Excuse me. Next up, Tango and November. Tango and November are in the exact same in the exact same grid. They are in the exact same column. However, they are not in the exact same row. So this is going to end up being the first column and the third row. This is going to be a delta. Tango and India. Tango and India are in the same little 3x3 grouping here. They are in the same row, however, they do not share the same column. This is going to be using the same row but different column. This is going to be a uniform. Kilo and Echo. Kilo and Echo is going to be Kilo is right there and Echo is right there. Kilo is going to be they're both in different groups. So it's going to be the first group because that's the one that's not being used right now. They are both in the same row. So first row. And they are in actually different columns. Echo is in the first, Kilo is in the second, which means it's going to be in the third column. So first group, first row, third column is going to be a Charlie. Next up, we have Golf and Romeo. Golf and Romeo are both in the same group right here in this little bit 3x3. However, they are both in different rows and different columns. So what this means is that this is going to be an echo. Since both of these guys are in 2 and 3, which means we're going to use row 1, and both these guys are in different columns, which means we're going to use column 1. Next up, and finally, for Kilo and Sierra, Kilo and Sierra, Kilo is in a different group. They're both in different groups, so that means we're going to use the first group. They are both in different rows, and they're both in different columns. So we're going to use the first group. We're going to use the third column, one of these guys right here, and we're going to then use the second row, which is going to be in India. Now, let's search this up because some of these words are a little bit weird. Caduceus, does this exist? It's a plural noun of caduceus, so this means that this exists. So now we have our final word into the module. This is what we're going to submit, and let's take a look here. So now, each of these gears will be shifting either clockwise or counterclockwise, and they will essentially be cycling between each of these guys. So this will shift counterclockwise, this will shift clockwise. So we're going to hit when the letter is highlighted, which we want to submit, we're going to hit submit, and it will actually it will pop up in the leftmost instead of the way that Pandemonium does it. It will pop up in the leftmost position as you'll see flip. And of course, if you need to reset the sequence before you hit submit, you can simply just tap one of the displays here to clear that suspicion. So next up, we're going to go to alpha. We'll hit that. So delta. Okay. Then uniform. Go this way. Like that. Then back to Charlie. Right there. Then echo. Then India, and now this should solve the module. And just like that, the module is solved. Let's go over one more example. I'm going to go through this a little bit faster because it is very, very easy to do this module. But I hope this makes a lot of sense. This is definitely one of the trickier ones out there, and especially with some of the words maybe not seeming like real words. It's important that you use Google search to search that up, because I didn't even know what caduceus was. I had no idea about the Greek or Roman heralds one, typically one or two serpents twined around it. So I did not know about that, but that's kind of the weird thing about this module, is that it doesn't use its normal word list as it would, for example, other Cipher modules like the colored ones. So let's take a look at one final example. Let's hope I can get this right. So I'm going to go through this a little bit faster because we've done an example, and hopefully you guys have followed along with it. But essentially what we're going to do is we're going to do the same thing. But I cannot stress you enough, please save yourself some time, and with the binary gear cipher, please, for the love of God, save yourself some time. Don't bother doing the columns, and set this up as a 4x4 grid. It will save you a lot of time, or do whatever you want. I personally don't care. As long as I'm teaching you guys how to solve the module, I will be happy. So let's take a look. So we need first the top letter keyword, I believe. To take the keyword from the top row, so limpers, and we're going to make our key here. So limpers. So let's copy this until we get more than 26 letters. Right there. And now what we're going to do is we're going to do the same thing we did before here. So we need to increase each letter by 1. All of these guys are unique, it looks like. So L-I-M-P-E-R-S, that's good. From L, we have Mike. We don't have November's, that's going to be next one. India, we don't have Juliet, that's perfect. November, from Mike, we do have November, we don't have Oscar. Papa, we don't have Quebec. Echo, we don't have Foxtrot. Romeo, we do have Sierra, but we don't have Tango. Sierra, we don't have Tango. We do have Tango, but we don't have Uniform. And from Lima, we do have Mike, we do have November, we do have Oscar. We do have Papa, we do have Quebec, we do have Romeo, we have Sierra, we have Tango, we have Uniform, and I'm starting to get a hunch that this is going to be sort of the new string, so it's going to be next up after Uniform is a Victor. Then India, we have a Juliet, we do not have Kilo. Then Mike, after the Victor, is going to be a Whiskey. Then Papa, after the Whiskey, is going to be an X-Ray. Then Echo, after the Foxtrot, is going to be a Golf, which we don't have. That's perfect. So Golf. Then Romeo after the X-ray is going to be a Yankee. Sierra after the Yankee is going to be a Zulu. Lima after the Zulu is going to be an Alpha. Moving your back around. India, we just recently did a Kilo. We cannot do Lima because we already have the Lima. So we're essentially going to be doing the Bravo for this one. Mike is going to be a Charlie. Papa is going to be a Delta. And Echo for the last time is going to be the Hotel. Yeah, Hotel. And just like that, we have created our key. All of them are being unique letters. So now, let's take a look at each of our numbers. So let's get our encrypted letter here. I did not mean to do that 3 times, so let's do the scan. Alright, so we have, in this case, we have Tango, Romeo Zulu, Papa Kilo, Papa Charlie, Oscar Lima. And then we have numbers of 4634316, and then next up, 335757 Okay, so now let's take a look and let's start doing some reversals here. So between 4 and 3, all we're going to simply do is just reverse Papa and Zulu, Zulu right here. Put that right there. Then between 6 and 3, a bit of a bigger range, so that's going to be Oscar Charlie, Zulu Papa, like so. So Oscar Charlie, Zulu Papa, right there. Then next up between 3 and 5, we're going to do Zulu Charlie Oscar, like so. Then between 4 and 7, we're going to do a Lima Papa Oscar Charlie, like so. Then between 3 and 5 again, okay, that's just simply going to be swapping the 3 and the 5 because the 4 does not change. So it's going to be a Papa and a Zulu. Then between 1 and 7, so we're actually just reversing the entire thing. So that's going to be a Charlie, Oscar, Zulu, Lima, Papa, Romeo, Tango. Get rid of that entire thing. And between 6 and 4 will be a Romeo, Papa, Lima, like so. So Romeo, Papa, Lima. And now we're done with the first step. So now let's get our stuff for the second part, which is going to be the binary. We'll get implore for later. We're simply going to ignore that, though. And we're going to get rid of these numbers. We don't need those anymore. And let's get the binary code for this. So we're going to do a 1000010. Okay, so now let's get this thing going. And we have the bonus letter of Tango. So Tango is where we're going to begin at this on our key here. And now let's delve right into it. So let's get our 4x4 grid of these binary numbers created here. And let's continue through this. So let's go here. Space. Space. Here. Okay. Alright, and we begin at 0, 0 always, so we're going to begin there. And now what we're going to do is we're going to go to Charlie from Tango, so we need to count how many times we do that. So that's going to be quite a ways away, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, nice. That's actually rather quite easy. All you simply need to do is go 1 back, which is going to take me to a 1, 1, 1, 1. So that's going to be a, let's actually put it below the encrypted letter, the encrypted word rather. It's going to be 1, 1, 1, 1 for that sequence. So now from 1, 1, 1, 1, and from the Charlie, how many times does it take to get to Oscar? Another long ways away. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's just 2 back. Nice. That's going to take me back to a 1, 1, 0, 1. And then from the Oscar to the Zulu, how many times does it take us to get there? So we're going to do a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Back 1. Perfect. That's going to be to 1, 1, 0, 0. So from the Zulu now to the Romeo, that's going to be another quite a ways away. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Back 1 again. Beautiful. That's going to be to a 1, 0, 1, 1. Okay. So now from the Romeo, back here, From the Romeo, we're going to go to the Papa. That's 1, 2. That's perfect. So we're going to go back to the 1, 0, 1, 1, 0, 1. So back to 1, 1, 0, 1, because shifting left twice, 1, 2. That takes us right back there. So now from the Papa to the Lima, that's going to be 1, 2, 3 to the left, as we can see right here. That's going to be 1, 2, 3 down to 0, 0, 0, 0. That's what we're going to note down right there. To 0, 0, 0, 0. And then finally, to Tango, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the right twice. We're going to do 1, 2, 2 finally, 1, 1, 1, 0. Now we're going to end at this position for the time being. So we're going to end at Tango, right there. Actually, did we begin where we end? Nice. We began where we ended. Nice. We're going to keep that stuff in our position, and now what we're going to do is we're going to create a series of, we're going to combine all of this together, and then we're going to create a 4 rows of 7. Like so. So 4 rows of 7. Let's do that. And now we're going to go to these binary numbers, which we're actually going to go to 1110 quite a lot. Okay, and we're currently at 1110. So what this means is that we're going to need to hit this twice because this is marked as a 1. Okay, this is a bit interesting. So we have to go 16 times to get to 1101. Excuse me, 1110. And now what we're going to do is we're simply going to take 16 and we're going to simply add 16 to that, modulo this by 26 because of the alphabet letters, and we're simply going to shift to the left 6. So we're going to go 1, 2, 3, 4, 5, 6 to Sierra. Sierra is going to be our ending position. We're going to end at 1110 because that's where we need to go, and now we're going to end at the Sierra. Now we're going to do the same things again because we need to go to 1110 3 different times. So we're simply going to be shifting to the left 16 for each of these guys because these guys are marked as zeros. We only need to hit them once. So we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to Whiskey. So over to Whiskey now, and then let's count 16 more. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to Lima. All right, now from Lima at this point, so from Lima, we need to count from 1110. We need to go left to 1011. So 1011 is positioned right here. We need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we need to go to the left 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to count that again just to make sure. I am selecting 13, so it's going to be a uniform. Okay, and now we're currently at 1110, and we're currently at uniform. So now from this point on, we're going to go to 1001. So 1001 from 1110 is simply right twice or simply shifting left by 14. So left by 14 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 to hotel. Okay, so then we're going to be going to there. So 1110 or 1001. So then over to hotel. And now, from this point on, we need to go to 1111. However, we need to do this twice. We're gonna hit 1111, and then we're gonna hit 111 again. 111 again. So we're gonna go 4, 5, 6, 6 plus 16, 6 to get to the 1111, then plus the 16 to hit it again is gonna be 22, or simply shifting to the right by 4 in the alphabet. So 1, 2, 3, 4 will take me to Papa. Way over here. And finally, from 1111, we need to get to 0000, or simply shifting left by 1. And then shifting left by 1 from the Papa is going to take me to a Mike. And now for the final step, let's take our key again. So let's get rid of all of this crap. And now let's split you guys up into the funny. This is probably my favorite part of this entire thing, is splitting this up. So let's split you up into 3 groups of 3. So let's do this. Oscar Quebec Foxtrot, Tango Victor Uniform up here, and then we'll simply split you guys up once more. And now let's see what we have here. With a hashtag. So now with these guys, so we have Sierra and India, So Sierra and India are in the same group. They're going to be in group 1 right here. So Sierra and India are in the same group, as we can see here. They are in different rows and different columns. So we're going to be using column 3, row 2, which is going to be a Romeo. Whiskey and Mike, different groups. So we're going to be using group 3 here. Different rows, so it's going to be row 2. And different columns, that's going to be a column 1. It's going to be alpha. Next up, Lima and Papa, same group, same column, different rows, so that's going to be a Sierra. Uniform Lima, that's going to be different groups, that's going to be group 3 then. That's going to be different rows, that's going to be row 3, and different columns, which is going to be column 3, which is going to be the hashtag, which, if this is a hashtag, it is the letter of the encrypted word. Instead, the letter of the encrypted word is going to be the uniform. Hotel Oscar is going to be here and here, just to make sure I'm recording. I really don't want to mess this up again. Hotel Oscar. Hotel and Oscar here, we have different groups, different columns, different rows. So we're going to be doing group 1, column 3, row 2. That's going to be a Romeo right there. Papa Romeo, same group, same row, different columns. That's going to be an Echo. And Mike, an Echo, is going to be same group. That's going to be group 1. Different rows, different columns. That's going to be a Sierra, because we have the Mike and the Echo in rows 1 and 2 and columns 2 and 3. That's going to be row 3, column 1. That's going to be Sierra. Let's search up if that is an actual word. It looks like it might be a word. Rest yours. Which is the act of erasing or scraping. So this looks like an actual word. That's perfect. So now let's submit this into the module. And let's see if this is right. So let's go counterclockwise, or let's go clockwise, actually. To get to the Romeo right here. Let's go counterclockwise. Right here. Then counterclockwise to Sierra right there. Then clockwise to uniform. Ooh, that's not what I want to do. Submit the uniform. Okay. Then Romeo. Then down Echo. And then back down to Sierra. And now we hit Sierra. The module solved. And just like that, my friends, is a solved module. As always, thank you guys for watching. Remember to stay crazy, stay cool, don't get lost in the gears, and I'll see you guys in the next one. Bye-bye.